right, in our next section on reactions of triacylglycerols, we are going to talk about hydrolysis. So again, I know I'm throwing a lot of reactions at you, but you have seen hydrolysis before. We're just applying what we've learned about how to break an ester bond to a triacylglycerol, which has 3 ester bonds. All right, so remember that hydrolysis uses water to split. And when we talk about hydrolysis of an ester bond, we're talking about breaking that ester and reforming a carboxylic acid and reforming the alcohol that had come together to make an ester. So think of it as being the opposite of an esterification reaction. So you've learned this in Unit 2. We're just applying it to a triacylglycerol, which has 3 ester bonds. So therefore, we are going to need 3 waters in order to break that, as well as an acid catalyst, which we're just showing a generic acid with H+. So a little different from hydrolysis of esters is in hydrolysis of triacylglycerols, we wind up with a glycerol molecule and we wind up with 3 fatty acid molecules. So they can be the same as in a simple triacylglycerol, or they can be different fatty acids as in a mixed triacylglycerol. Whatever you have to start should be whatever you wind up with in terms of your fatty acids. So in order for this to happen, you will need, in this case, in this example, we've used an acid catalyst, but you could also use a strong base, or you can use an enzyme for this. So let's walk through this. All right, so in this case, we are going to break the ester bond right where we formed it between the single oxygen and the carbonyl. To that, and I would like to draw a single water molecule like this because we have an hydroxyl group going to the carboxylic acid, so the OH is going to attach to the carbonyl carbon, reforming the carboxylic acid. And the H is going to attach to the oxygen on the glycerol, reforming a hydroxyl on the glycerol molecule. Let's do some practice. Alrighty, so we have a triacylglycerol, we have water, and in this case we have an enzyme. And this enzyme I'm sure you've heard about hopefully you've heard about in anatomy and physiology. Lipase is an enzyme that breaks down fat. So here we have a fat, because a triacylglycerol is a fat. And this is drawn in a way that doesn't emphasize the ester bond, so we have to be careful about how we go about finding our ester bonds. So let's just highlight our ester right here so that we know exactly where we're breaking these bonds. So we're going to have a molecule of water. We're going to split, go back to my pan. We are going to split our ester bond between that single oxygen and the carbonyl in each location. And remember that our glycerol, so this portion is going to reform, it's going to get a hydrogen, 1 hydrogen from each of the water molecules. So I'm going to start by writing that first. Forgive my handwriting. All right, so here is basically what I have when I make that split, is I'm going to reform my glycerol molecule. Put that oxygen the way I've drawn the rest of them. Okay, so this is going to be my glycerol. I'm reforming that, and that is important for us to memorize. And I'm going to draw the H from the water. I'm reforming that. So I'm going to have 3 hydroxyl groups on my glycerol backbone. I'm also going to have 3 fatty acids that reform carboxylic acids as a result of this split. So, this is going to benefit you if you make sure these are identical fatty acids, which is going to make my life a lot easier. So I can use a coefficient of 3 to say I'm forming 3 of this one molecule. It's going to save me a ton of writing. So I am going to start by drawing the chain as it was before we touched it. Okay, so carbonyl on, CH2, 10. Oh, I'm going to run out of space. Oh no, CH2, 3, and I'm going to put the little methyl group here. Hopefully you planned better on your paper than I did on mine. All right, so I'm going to draw again the OH group that came from the 3 waters reforming my carboxylic acid. I'm going to put that in green. So that OH group, and just to give you some color reference, the H from it went to the glycerol and the OH went to the carboxylic acid. And again, I don't have to name this. I just have to show the products. All right, guys, it is your turn to give this a try. Notice that we have a mixed triacylglycerol. I'm not going easy on you. So you guys are going to have to break these ester bonds through hydrolysis, and you're going to have to give me 3 different products on this because they are all different fatty acids that are going to form. If you're following along, this is a question in your guided practice. You could do it on there rather than copying it down if you'd like. But go ahead and pause the video and give it a try. All right, so here's the solution. Again, I'm going to go in and I'm going to draw that line in the sand between my single oxygen and my carbonyl because that to me is a signal to my brain. This is where it splits back into the original glycerol molecule. And then each one of these is going to become its own fatty acid that I add the OH back to. So here would be the bottom fatty acid, the middle fatty acid, and the top fatty acid, and they're all separate now, and I cannot use that 3 for this because they are not the same, so I can't condense that anymore.